Good morning to everyone. I am very glad that before my talk we discuss about budget and we discuss about multi-species management. That is one of the most serious problem for installation that manage species at multiple scale and in time with variable budget. Let me adjust the PowerPoint presentation and everything should be okay. So I'm Matteo Convertino, Dr. Matteo Convertino, and I work in the Igor Linkov Group, Risk Decision Sciences in Boston for ERDC, and I'm also a research associate at the University of Florida, Department of Agriculture and Biological Engineering that belongs to IFAS. So today I'm going to talk about species management for DoD installation, proposing a portfolio decision model. And I will focus my example on Eglin Air Force Base. So this work has been done with Kelsey Baker, recent undergraduate at MIT, Dimitri Dokukin, that is our software engineer, James Valverde, former professor at London Business School of Economics, and Jeffrey Kissler, that is a professor of Management and Information Sciences at the UMass Boston, and Igor Linkov, that is the team leader. So this is supposed to work. So as we discussed before, Eglin has to deal with multiple species, and I list here 25 species that are documented and 3 that are likely to be to occur. I derived this from the FNIA database, from which you can derive the species occurrences. So reminding our conversation last year, we discussed, for example, the endangered perforated lichen, the turtle, the beach mice, and so on. So, speaking about, for example, management alternatives, every single species has a different set of management alternatives that are possible, or some of these management alternatives are the same. For example, here I've created an example of a snowy plover, piping plover, and red knot that are contained in our proposal. And for example, for snowy plover, we have like that one conservation management option is the creation of ephemera pool, restoration of dunes, creation of the sparse vegetation, monitoring, and no action. Because also no action can be one of the possible management alternatives. Of course, all these alternatives have associated costs. For the snowy plover, some of them work, and for some other not. For the red knot, we have more or less the same alternatives, but this may carry different costs. So let's think about Santa Rosa Island, for example. We have this portfolio of conservation alternatives, and we have a different land use by the military installation. So for example, if you think about the red pixel as pixels that are highly used for training purposes, yellow pixels that are less used for training purposes, green are much less used than yellow, and blue that are not used. However, we need to consider that in order to perform these conservation alternatives, the installation has a budget. This budget is allocated to this kind of enterprise scale, and decision makers must balance the benefit of each species with the cost of management. This has to happen simultaneously in order to determine the optimal set of management action with the budget constraint that will result in the greatest benefit to the installation. And when I mean installation, I mean a social ecological system. Social because there is a human component, that is you, that you need to train, and ecological because of course we have also the species. Our research aims to be a translational research, meaning that we perform basic research, we have published a lot, we have an integrated set of models that can be used to any species. So for us, right now, the purpose is to come closer to you and to offer this set of tools in order to be useful. Okay, so let me explain this triple bottom line preview of the model. We have 3 different scales. At the top of this pyramid, we have the enterprise, that is the installation, in this case Peglin and first base. At the second level of this ecosystem, we have the species, for example, piping plover, snowy plover, red knot. However, we can include every species that you are interested in. For each species, we calculate the potential risk. The potential risk is split into vulnerability, exposure, and hazard. And this one is according to the classical theory of risk assessment. Also, we consider different cost of a person alternative for each species and different benefits for each species. So when we talk about benefits, we calculate those benefits through a multi-criteria decision model. The NCDA score that come out of the multi-criteria decision analysis, together with the cost of each single alternative and together with the potential risk, go in input in this portfolio model in order to determine the best set of conservation alternatives that is feasible according to your budget. So let's define better what is the hazard for us. The hazard is the product by the vulnerability that is the intrinsic vulnerability of the species, the exposure, that is a variable that varies in space and time and is derived by habitat suitability model, and the hazard, that is itself also a variable that varies in space and time. The hazard in our case is the military training. So this potential risk is can be calculated at different level of complexity, because, for example, the vulnerability, the exposure, and the hazard can be calculated in considering different scales of precision, different approximation. And for example, the vulnerability, that is the one that I'm talking about, actually not. Let me talk about the exposure first. Okay, in our case, the exposure is calculated, as I said, based on the presences that come from the FNIA matrix. And in a sense, this one is an easy way, because it's a coarse scale data, and we can refine this information, for example, using habitat suitability model, or together with this habitat suitability model, we can couple also an engine that move the species and trying to simulate that dispersal. So we have a probabilistic description of where these species are. The vulnerability has been calculated, downloaded the abundance curve and the risk from the knowledge network of biocomplexity portal that gives the information. However, if we wanted to be more precise, thus adopting a different, more precise level of complexity, we can adopt a metapopulation model. So, because again, as Greg said and Maria said before, our focus was on the snowy plover, we adopted the habitat suitability model and the metapopulation model only for the snowy plover. For the red knot and for the piping plover, I just use this simple estimation of vulnerability and exposure. Why our tool is better than classical multi-criteria decision analysis? So, first of all, we consider simultaneously the combination of several management alternatives for each species, rather than ranking each alternative individually for the species. What's the meaning of this? The user, that is the decision maker or the scientist, combine the most valuable alternative from each species to reach the maximum total value. So in that example, if you consider, for example, alternative 1, 2, 3, and 4, each of those alternatives has a score for each species, meaning alternative 1 can be good for piping plover, but as you can see, it's not the best. But for example, the piping plover does not score better if you adopt alternative 2. And in classical decision analysis, the alternative that is considered is alternative 4. Why? Because it presents the biggest, the highest value of the highest cumulative value that comes out of the MCDA for each species. So, but that, as you can see, does not guarantee that you have the highest value for all the species singularly. So the optimized set is the one that takes the maximum value for the snowy plover, the maximum value for the piping plover, the maximum value for the red knot. And this score can belong to different alternatives. So you have a combination of different conservation alternatives. Now, the question is that set of operation alternative feasible? That means, are you capable to do that in space, in combination with all the other species, and respecting the budget that you have? Here you have an overview of the tool of the multi-criteria decision analysis. I have the criteria, I have sub-criteria, I have weights that can be inferred interviewing stakeholders, and some of these criteria are maximized or minimized. For example, we have that the training intensity is of course maximized, the habitat is maximized.